Chapter 5, Section 5 is about inequalities that involve absolute value. Before we get too far into this section, I just want to remind you of one thing regarding absolute value. Anytime that you're dealing with absolute value, you're going to see those bars that kind of look like parallel lines almost. They've got stuff in between them. And anytime that you have something inside of those absolute value symbols, whatever it is always going to come out as positive. Okay? So I want you to remember that if we had a sentence like this, x in absolute value is equal to 14. Let's say that's what they gave us. There are two options for what x could have been. X could have equaled 14 because the absolute value of a positive number is still positive. Or x could have been negative 14. Because if I put in a negative in absolute value, it comes out as a positive number. So when we solved absolute value equations back in chapter 2, we had to set up two separate equations in order to solve them. So when we're solving absolute value inequalities today, we're going to have to set up two separate equations as well. So for example, this first one we have says the absolute value of 2x is less than 6. If you remember when we solved these in chapter 2, the first equation looks exactly the same. So everything drops down, we just get rid of those absolute value bars. So you can see how it says 2x is less than 6. Now, the second case is you're still going to bring down the 2x, but when we did these as equations, we had equal signs. And so we had to change the number after the equal sign to the opposite sign that it was. So anytime that you're dealing with these, in order to actually solve them, you're starting with a positive number and then it's switched to negative. Because we are dealing with absolute values, we also need to make sure that we switch our sign. So that is another big thing that you're going to want to make sure that you try to remember to do. So when I write out the second one, it says 2x. We switch that less than sign to a greater than sign. And then it also says negative 6. So now if I'm going to solve these, I would divide both sides by 2. And I do that on both of these equations. So kind of similar again to what we did in chapter 2 and kind of what we saw last section as well when we're solving these equations 2 times. The solving process looks a lot of the same. Okay, so I'm going to write my answers down underneath this note. So I've got the first one says x is less than 3. And this one says x is greater than negative 3. They have that word and in the middle. And that's just telling me that it's going to be able to have a graph that has some overlap. So when I go down to my number line, I would put negative 3 and positive 3 on my graph. Again, make sure you put the negative over here on the left. Both of these are going to have open circles because those symbols do not have equal signs. And we're shading in between. It also makes sense if you just kind of read this, x has to be less than 3, which would be going from positive 3 to the left. And it has to be greater than negative 3, which would be starting at negative 3 and going to the right. So they would indeed shade in the middle here. Another way that you might see that answer, I guess I did have a number line down there. You'd have a solution set here with those answers that we found written as a compound statement. So again, we saw a little bit of that last section. If you're keeping your answers separate, it's not a big deal. You don't have to write it as a compound statement, but just know that you might see that, especially moving forward in other math classes. So what I want us to do on this practice problem here is I'm going to go ahead and help you get the two equations started, and then I want you to finish them by solving them and putting them on the number line. So if you remember what I said on that previous one, the first equation is going to look exactly the same, so we just drop everything down, except for those absolute value bars. We kind of just get rid of them. And then for the second one, we have still the 2x minus 3. We switch the inequality sign, so it says less than, and we change the sign of that 1, so it says negative 1. So make sure for that second equation that you do both of those changes. Go ahead and take a couple minutes here, solve both of these equations, put them on the number line, and then there's some follow-up questions underneath here, underneath the number line, that I want you to try to answer. So if you need some more time, which you probably do here, I want you to pause the video, finish working this out, and then resume watching when you're ready to see what it should have looked like. So for this first one, well, really for both sides, the first step is to add 3 over. So you would have 2x is greater than 4, and 2x is less than 2. Then we should have divided both sides by 2. So we have x is greater than 2 and x is less than 1. When I came down here to my number line, I put 1 on the left, 2 on the right, open circles for both of them. And when I graphed, x had to be greater than 2, that means we would shade to the right. X also had to be less than 1, which means we shade to the left. So to answer our follow-up questions down here, this is an OR graph because they shade in opposite directions. Now these next couple of questions are going to start getting us back into if we had to write out the absolute value equation. So they're starting to have you try to retain or kind of bring back some of that thinking that you had to do when you did this in chapter 2 for absolute value equations. So that's figuring out like what the middle of the graph would be. Now if you don't remember how to do this, to find the middle of an absolute value graph, or really of any graph, you would add the 2 solutions that you had. So in this case it would be 1 and 2. You add them together and then you cut them in half, so you divide them by 2. So this would come out to be 1.5. Okay? And then where are the endpoints in relation to the middle? They would be half a step away, because like 1.5 would be like right here. So I would say each solution is half, or 0.5, a step away, because they're asking why. We would say because they are, I'm going to throw a fancy word here that you may not have heard before. It's equidistant, which that means equal distance. Okay, so if things are equidistant, that means that they have the same distance away from something. So since we're talking about the middle of the graph, the 2 solutions would have the same distance away from the middle of the graph. So it makes sense that they would be considered equidistant because they're going to be the same distance away from that middle part. Now again, the reason why we're reviewing this or kind of having you start thinking this way is because the next example is going to want us to be able to write out an equation to represent the absolute value graph that we're looking at here. So in order to do that, you're going to have to figure out what the middle of the graph is, because we need that piece. So step 1 is to find your middle. So on this example up here, my solutions are the 4 and the 10. So I'm adding those together and dividing it by 2. So they got the middle to be 7, which would be right there. Now you need to figure out like how far is 7 from your 2 solutions. It should be the same here on both sides because again, that equidistance. What we did a lot in chapter 2 is we just took the biggest solution, 10 in this case, and we subtracted the middle, 7, and we got 3. So when we write out our equation, coming down here, you put in those absolute value bars, x minus, if you remember again from chapter 2, it's always x minus the middle. So you might also want to just maybe put this somewhere. It's always x minus the middle. And then we set it equal to the distance, which represents the distance from the middle to your solutions, okay? So 7 was the middle, 3 was how far the middle was from our two solutions. So that's where those are coming from. Now, how did they get this symbol here? How did they know that it was less than or equal to? And if you look at the graph up here, it's shading in the middle. It's overlapping. So when they share, that's an AND graph. And in a couple sections ago, section 4, we talked a lot about how less than means and, okay? And then we said that greater than means or. The reason why this one's less than or equal to is because both of those solutions up above are colored in. Both the circles are colored in. So that means that you have to have an equal sign. If the solutions didn't have those colored in circles, if they were left open, then you would just have a less than sign. Now, if you happen to see an OR graph, so if the shading goes away from each other, then that means that you would have a greater than symbol inside of your absolute value graph equation. Go ahead and take a minute and practice this. Okay, what I would have done first on this one is found the middle. And to do that, I would have taken -2 plus 16, cut it in half. That came out to be 7. Then I would have figured out how far is the distance from 7 to the solutions. An easy way to do that would have been to take 16, that last solution there, subtract the middle, which gives you 9. Then we write the answer, which is absolute value, x, minus your middle, which was that 7. And then you have the 9 here. And to figure out what symbol you had, the shading, again, is in between the two solutions, which means that I need a less than symbol. And they are colored in circles, so I need that equal sign as well. Okay, so to kind of summarize what we just talked about there, we're finding the middle for your first step. You're figuring out what the distance would be from your middle to your solutions. And then you look to see, is it shading towards each other or away from each other to figure out, is it less than or greater than? And then you're putting it into the absolute value equation, okay? Now, we can apply this to a couple of other situations like word problems, story problems, or if they're just kind of describing a situation to us, which is what we're going to see next here. So this first example wants us to write out an absolute value equation for numbers that are at least 3 units from -2. So if you're going from -2, that means that -2 had to be in the middle. And then 3, that would be the distance, because they're saying that it has to be at least that far away from the middle there, the middle of that -2. So they're saying that the middle is -2, the distance away would be 3, and they would then write x, like it would have started x minus -2, but remember, anytime that you see double negatives, you end up adding them. And then your 3, now how they got the greater than or equal to sign is they're saying that it has to be at least 3. So 3 is like the smallest amount away from the -2 that you can be. So it has to be 3 or more in order for it to work for this problem. So 3 or more would be leading us towards a greater than type problem. So that's why they're using a greater than or equal to sign. Okay, now let's take this and apply it to a word problem. So this says that you obtained a job working for a siding company. On your first job site, the siding for a house was 9 feet long. Your job is to cut the siding pieces. You cannot be off by more than 1/8 of an inch. We want to write the absolute value inequality that represents the size that the siding can be. So I want to figure out kind of some of those key points that we were just talking about, like what's the middle and how far from the middle can we be so that we can write out our equation. Okay, and kind of like figure out like what symbol you need. So step one is to figure out what the middle is. Each piece of siding is 9 feet long. So I would say that that's probably your middle because that's going to be the length that you're using. Now, how far off your cuts can be, they say is 1/8 of an inch. So your distance would be 1/8, so 1/8 there. Then it says that you cannot be off by more than that. So the most that you can be off would be 1/8 of an inch. So it has to be 1/8 or smaller off. Like that's your margin of error that you have. Which would mean that I need a less than or equal to symbol because it could be up to 1/8 of an inch. So to use all this information here, to basically go into step 4, which is to write the equation, we do absolute value of x minus our middle, which is 9, has to be less than or equal to 1/8. And then you want to find what the range would be if they asked for that. Now, this doesn't go on to say, like, what would be your range, but you could always take that to figure out what the range would be. Remember to set these up, you would do one that says x minus 9 less than or equal to 1/8. And the other one would be x minus 9 greater than or equal to negative 1/8. And then you would add 9 over for both of these. When you do that, x has to be less than or equal to 9 1/8. So that's the most that it could be. And the second one would be x has to be greater than or equal to 8 7/8. So those would be your range of cuts from what the original siding length would have been. So I want you guys to go ahead and try to do this on your own now. Read through this next practice problem, and then try to do the same things. I would do the same 3 steps. Find the middle, find the distance, figure out what symbol you need, and then go ahead and write out your equation. And this one is asking specifically for the range. So for this one, I found the middle to be 89. The distance would be 3. Your symbol would be less than. So then we would have x minus 89 less than 3. And your range would be that you could have a weight between 86 and 92 pounds.